All right, my amazing students, we're going to be tackling our final example in the inscribed angle section, which this problem pertains to inscribed quadrilaterals, which if you think back to when we talked about all those nifty segments going through triangles, we talked about what an inscribed circle was, which an inscribed circle is a circle, or anything that's inscribed is like inside of another object. So like when we talked about the in-center, the reason why it was called the in-center was because it was the center of an inscribed circle, which is a circle, inside of a shape, but now we are reversing that statement. So now we're talking about an inscribed quadrilateral, which is a quadrilateral inside of a circle in this case. Whoa, right? Guys, so we're doing example 5, which the demon cats did get me. Okay, so I forgot to actually write out the problem for example 5. I squeezed it up here so it's really hard to see. It says find all the angle measures in quadrilateral PQRS, which if you cannot see that, just look at this slide of the Prezi. If you want to pause the video and copy that down, that might be a little bit better. Guys, but the theorem that we're going to be talking about is on inscribed quadrilaterals. So let's do a quick recap of that. So inscribed quadrilaterals, if you remember from the Prezi, opposite angles in an inscribed quadrilateral, which is a quadrilateral inside the circle, they are going to be supplementary, which what does it mean to be supplementary? It does, in fact, mean that they add up to be 180. So in a quadrilateral inside of a circle, opposite angles add up to be 180. So angle B and D add up to be 180, as well as angle A and C in this picture. So they are supplementary. So we're going to be using this nifty theorem to help us solve for all the angles in this lovely quadrilateral right here. But before I can start finding my angles, I have y's in my angles, okay, which that's going to be a problem. If I don't know what y is, then I can't find what all the rest of these lovely angles are. So I need to find what y is first. Guys, which I know it's kind of hard to see. Again, hopefully you looked at the Prezi to get the angles because my handwriting is not very good in this problem. But anyways, angle P is 6y plus 1, angle Q is y squared plus 48, and angle R is 10y plus 19. Okay, so based on the angles that I have in my quadrilateral, which ones would be helpful for me to solve this problem? Well, Q is not going to be very helpful because in order to solve with a quadrilateral inside of a circle, I need an opposite angle, which I don't know what S is. So the angle across from Q is S. It's its opposite angle, and I don't know what that is. So that's not going to be helpful. So do you guys see two angles that are opposite of each other that might have some information that is helpful? You guys are so smart. Too cool for school, you guys. So angle P and R, they are across from each other. Okay, this angle is across from that angle, so I'm trying to draw across there. It was through my other angle, so I apologize. Okay, so that means that they're supplementary, which means they add up to be 180. So let's set up this bad boy. Okay, so the measure of angle P plus the measure of angle R adds up to be 180 because they are supplementary. All right, let's solve this thing for y. So I'm going to start filling in my values. Alright, so what is the measure of angle P? Holy hot dog, the measure of angle P is 6y plus 1. The measure of angle R is 10y plus 19. Heavenly hamburger, right? Equals 180. Alright, let's solve this bad boy for y. So I'm going to combine my like terms, which 10 and 6y are like terms, which 10 and 6y will add to be 16y. Okay, plus my other like terms are the terms without the y, so the 1 and the 19, which those two add up to be 20, the 1 and the 19. And they should add up to be 180. All right, let's keep going. So now you get y on one side by itself, which this 20 is currently irking me. How do I move 20 to the other side? I would subtract 20. Okay, so 20 minus 20 cancels and turns to 0. 180 minus 20 is 160. And like normal, I'm running out of room. All right, so I'm going to bring this up here. Okay, so what I'm currently left with is 16y equals 160. All right, as we're so close. Okay, I need to get y by itself. Okay, the 16 is secretly multiplying to the y. So how would I move that bad boy to the other side? Indeed, I would divide both sides by 16, where 16 divided by 16 cancels and turns to 1. So I'm left with y equals 16 divided by, 160 divided by 16. Well, 160 has a 0 on the end, which means if I multiply 16 by 10, I'll get 160. So this bad boy will equal 10. So y equals 10. But we are not done, people. This problem, which is very hard to read, says to find all the measures in the quadrilateral. So I need to find all the angle measures, which are angle P, R, Q, and S. Okay, which 3 of those angles have a y in it, which is going to help me to solve. So let's get started on that. I'm going to start with angle P. Might as well, right? P is a pretty nifty letter. All right, so what is the measure of angle P? The measure of angle P is 6y plus 1. Which now that I know that y equals 10, how can I use that 10 to help me find the measure of angle P? I can substitute that bad boy in for my y. Okay, so measure of angle P equals 6 times y, which is 10, plus 1. All right, so the measure of angle P equals 6 times 10, which is 60, and 60 plus 1 is, 61 degrees. So we got one angle down. Yes. All right, let's keep going. Okay, so the angle across from it, now technically I could kind of figure it out because opposite angles are supplementary. Okay, so I know that these two add up to be 180. So I could solve it, and then I could also do a little check to make sure I did it right. Okay, so I know that the measure of angle P plus the measure of angle R equals 180 because they're across from each other and supplementary. Okay, which we know the measure of angle P is 61 now. So I'm going to replace that bad boy with the 61. So 61 degrees plus the measure of angle R equals 180 degrees. All right, and I'm really close to finding what R is. How do I bring 61 to the other side? In fact, I would subtract both sides by 61, which 61 minus 61 cancels, bam, karate chop, turns to 0. And 180 minus 61, well, 180 minus 60 is 120, minus 1 more is 119. So the measure of angle R is 119. So technically, I could be done with that one. But it's always helpful as a mathematician to check your work. Guys, and since R has a y in it, we might as well substitute in y to see if we end up with 119. So I'm going to do a double check. It's always good to double check your work. I mean, really it's good to like quadruple check your work, but we don't got time for that tonight. So we're only going to double check. Okay, so the measure of angle R equals 10y plus 19. Okay, and since we know y is 10, I can substitute 10 in for y to get r, so let's get going. So the measure of angle r equals 10 times y, which is 10, plus 19. All right, and 10 times 10 is 100. And 100 plus 19, Jiminy Cricket, it is 119. Look at that. So our work checks out. Yay, and we're excited. So I'm going to draw a smiley face. Okay, so far we're on the right track. Let's keep going. And the measure of angle Q also contains a y, so I'm going to use y to help me find the measure of angle Q as well. So the measure of angle Q equals y squared plus 48, which means the measure of angle Q equals y squared, which y is secretly a 10, so this is 10 squared, plus 48. All right, so the measure of angle Q equals 10 squared, which 10 times 10 is 100. And 100 plus 48 equals 148 degrees. Bam, chicka bam. All right, guys, we're getting close. We got one more. Now, the measure of angle S, it doesn't have a Y. Oh, no. All of our angles have had a Y in it, but now we don't have a Y in our angle. So what are we going to do to find the measure of angles S? Is there another angle in our quadrilateral that just might help us find the measure of angle S? Sorry, cannot talk today. Well, there's several ways you could approach this problem. Do you guys know what the total angles in a quadrilateral adds up to equal? Well, all the angles in a quadrilateral add up to be 360. So since I know 3 of the angles, I could add them all up and subtract from 360. That's one way. Another way is there one angle in particular that is across from S that might help me using the inscribed angle or inscribed quadrilateral theorem that we talked about earlier today. Well, angle Q is across from angle S, and in an inscribed quadrilateral, opposite angles are supplementary, which means they have to be 180. So I know that the measure of angle Q plus S will have to be 180. So I'm going to use that value to help me solve. But you could do both methods and then check your work as well. So either way. All right, so I'm going to do the measure of angle S plus the measure of angle Q should add up to be 180 degrees. All right, let's get this bad boy started. So the measure of angle S plus the measure of angle Q, which I already know is 148 degrees, will equal 180. Okay, so the measure of angle S, well, actually, I didn't even do that. I want to get the measure of angle S by itself, so I need to move 148 to the other side. Sorry, guys. How do I move 148 to the other side? I do subtract it on both sides, which this one cancels and turns to 0. Okay, and then 180 minus 148. Sorry, that says 148. I'm going to zoom in so you guys can see it a little better. So that's a 148. So 180 minus 140 is 40 degrees. Minus 8 more is going to give me 32 degrees. So the measure of angle S, I'm going to cross that one out, so I don't need it. The measure of angle S equals 32 degrees. Bam. All right, and then if you wanted to make sure that this was right, you could take all your angles and make sure they have to be 360, which guess what, you guys already did that. But if you want to do that, you can to make sure that all the angles in your quadrilateral have to be 360. Oh man, you guys, wasn't that spectacular? We found not 1, not 2, but all 4 of our angles. Nice job, you guys. That was amazing. Thanks for sticking this problem out with me.